Okay, so, well, thanks everyone for joining, especially today that is Thanksgiving in the United States. So I guess people from the United States will be watching the video later in YouTube. But for everyone else around the world, welcome to the SAF Community Stand-Up of November 2024. I'm so happy that we made it so far. It's been like 50 community stand-ups so far. And today is going to be a really interesting topic because we're going to talk about the new Microsoft AI extensions, which is something that a building block that is a little bit separated from the other framework that is semantic kernel. Eventually, we're going to do a comparison of semantic kernel and Microsoft AI extension, but so far they are both experimental and they are both outside of the core part of the framework, but both are really interesting and they are for different use cases. So I'm going to share this repo in the chat so you can take a look to it if you want. It's public, you should be able to download it. And here are the use cases that we're going to check today. So these use cases are based on Steve Sanderson demonstration that happened last week, I think, in the last Microsoft conference. Javier was actually there. I'm still in Europe, so I could not attend. But basically, what I did is I checked the conference videos and then um, I port those examples to SAF. So what we will see today are the same examples that he's shown, just integrated with SAF. So funny, there is someone in the audience that has my same last name, and maybe he's from Argentina or from Spain. I was born in El Salvador, and my last name is totally strange in that I'm almost unique. But in Chile, that my family is from Chile, actually, it's a really common last name. So that's interesting. Okay, yeah, so let's see. Let's continue with this. So, okay, here is the repo and it's public, and now it's time to see some code. So the first thing that I want to show is that everything that I'm going to show is actually compiled in .NET 9. As we know, SAF applications are just regular .NET applications, so there is nothing special on changing the target of to compile it. So also, I think that the people from Developer Express posted like 2 weeks ago when .NET 9 was released that everything is, I mean, you can compile it against .NET 9. So that's one of the main things here. And just to show you here is like we are working with .NET 9 at this moment. And even though semantic kernel works with .NET 8, it's better to use it with .NET 9. Also, the Microsoft AI extensions, they target .NET 9 in general, so it's better to be in this version. And I've been testing .NET 9 since the release, and basically it's fine. Everything that work with 8 will work with 9 without any change or problem. So far, so good. So let's start with the most easiest case. The first case that we are going to see is here. Here you can see also, before we move to the code, you can see also the architecture, how this is working. So you see like the Microsoft AI extension, they are a really core part of the framework. They're supposed to be like really into the framework. So they are like base types. And most of them are interfaces with implementation. So maybe you have noticed that since we moved from Net Framework to .NET, a lot of the technologies divide themselves on the abstractions and then the implementations. So just to show you the example of that in here, if we check the reference in the module, um, let's see the module, you'll see that we have the extensions and then we have the abstractions. So basically, the abstractions are all the base types, like the interfaces and the abstract classes, and also some extensions that they are implemented in a specific vendor, a specific provider. That's too specific there. So as you can see here, we have the abstractions, and then we have Olama and OpenAI. You can use also Azure OpenAI. That is a little bit different than OpenAI. Basically, it's a different set of servers, but the API construction is the same in the end. And also, for some cases, we need other extensions like caching, hosting, and logging. And one that is really important is the numeric tensors, because we need the reference to numeric tensors to do a similarity search or cosine search. So going back to the website, so this is the official post of the release of the AI extensions, and here they show you the architecture. So it's, as you can see, it's really um, deep down the framework. So it's supposed to be the base types. So before you have to make your own chat class, your own message class, and now they provide all those abstractions for you, even though there are like several implementations across the .NET world. For example, OpenAI have their own implementation of message. Developer Express has their own implementation of message. And most people who have been working on this for like 1 or 2 years will have their own implementations of message. So the idea is to consolidate all the possible implementations and say this is the basic contract, which is an interface usually, and then you can start growing from that. So you don't have like so many different implementations across your application. Okay, so we will start with the most simple case, which is generate embeddings. So this one is, embeddings is basically from a text, you generate a numeric vector, and then you can do semantic search over those vectors. So here in the module, we have one class. This class is basically a normal domain object. We have code, we have text, and then we have an array of floats. This actually is not, it's not a persistent type. It's not supported by XPO. That's why I created a value converter. So the value converter will convert basically the float array to string and from a string. If we check this implementation, you can see that in here to array will basically take the array and save it as a string. And the other implementation will take the string and then return you an array. So with that implementation, you can actually do something. Let's check the embedding controller. So in here I have basically three actions. Let's check the generation of embedding. So this one, we get the embedding generator. That you can see the embedding generator is an interface. And then here we have an implementation, which is the Olama embedding generator. This means that this is going to use the Olama models running on my computer. And to show you that this is a base class, you will see that this class here will implement the I embedding generator. So let's go here. Go to definition and let's go up a little bit. And then you can see that this implements the I embedding generator. And you will have one for OpenAI, you will have one for every other vendor, for Azure OpenAI, and so on and so forth. So basically, this is the only part that will change in your code. And everything else, since you're referring to an interface or a base type, you don't need to change the code, even if you change the vendor. So this, I can change it for OpenAI, and it will actually work. But in this case, just to explain a little bit of what this code does is we create the embedding generator. We're going to use the Olama running on my computer, and then we're going to use this model, mini LM. This model, sorry, is the one that you use for creating vectors and embeddings. Not all the models are able to create vectors. Some models are specifically to create vectors, and some models are specifically for chat and so on and so forth. So this one is specific for generating vectors. So here we just get the generator. Then the generator, you can pass a text. With this text comes from the object that I showed you before from this class. And after that, it's super easy. Basically, it will generate a vector, which is an array of float. And this one, we save it on the XPO object. So let me show you that running. Let's run it on Windows so you can see that this is also platform agnostic. And let's put a breakpoint here. I think this is the last community stand-up that this computer will see. I ordered a Microsoft Surface, the new one, with the NPL. So in the next stand-up, I hope my demos will run faster. So let's see. Even though this is a really nice computer, but I don't know what happened when you're using so much, something die inside of them. It's like they're getting degraded somehow. So let's see. Here we have our SAF application running Net9. And let's see, I pre-generated some embeddings before. So here we have the list. So here I have 3 embeddings. So the embedding has a code, a text, and the array of float numbers. These are actually the vectors. So this embedding about my home country where I was born, El Salvador, just something that I got from Wikipedia. And then I got one for Cuba. Javier was born in Cuba, so this one I got it for him actually. Here are the float numbers or the array that represents this vector of this text, all the vectors from this text. And last one, we have one from Dominican Republic, which a lot of the people in our office is from Dominican Republic. So, and here again, the vector that is there. So let's generate a new vector. So let's create a new one. So I will type this. SAF, so we didn't type SAF is an application framework for .NET 9. Okay, let's save this. And right now, when I click generate embeddings, it's going to take this text, take it to the embedding generator, and then save the array of floats. So now it's actually running. It should be running in the background. And there you go. It's done. And here we have the byte array. See? Perfect. Okay, so these are the vectors that represent this sentence. Now that we have these vectors, we can do a few things. But before we move forward, I want to show you one other example. In this case, I just did a single text. So from the embedding generator, I passed the text and I got the result, and then I save it in my object. There are other ways to do this. Basically, you can use a set of text. You can send a list of text or an array or any enumerable of text. So for example, in this case, we are getting the embedding generator exactly the same, but we are getting all the objects in the database. And then we have this different method, which is generate and zip. What this is going to do is it's going to generate this structure here. This is basically a tuple. I don't remember how to pronounce it well, which is on one side is the string value that we pass, and then in the other side is the vector. So you can use this in case that you have a list of text and you want to generate several embeddings by record. And then you can use that to do semantic search. So I'm going to run this one. This is basically going to get all the text from the objects that we have and then generate this as a single object, which is an array of the values, I mean, the string value and the embedding. So basically, it's kind of the same. So we'll generate zips. So first we have here the strings. So it's the text from El Salvador, Cuba, what is SAF, and Dominican Republic. And now here we have the structure. So you have both the key and then the vector. So it's just a different way to generate it. Okay, so after that, once we have this, we can do a semantic search. Just let me show you the code a little bit. It's like super simple. So for the semantic search, basically I have a parameterized action where I get the string value of the action. And then again, what I do is using the embedding generator, I pass the value from the parameter. So here you have the parameter value, and then we generate an embedding. So we will basically generate that vector, that set of numbers. And then with that set of numbers, we're going to compare it to the ones that we have already stored in our database. In this case, the comparison will be done in memory. Why? Because um, some databases are able to do a specialized vector search inside of the database in the engine without having to take the information out. But since we are not using that case at the moment, even though I want to show it in the future, what is going to happen here is that we're going to load all the embeddings that we have saved already. Those already have the vectors on them. I mean, the column with the float numbers. And then in those vectors, we're going to do this. This is kind of easy to understand. So we have all the embeddings, and we're going to do a similarity search. So we're going to run the cosine similarity, and then we pass the embeddings, and then we pass the input. So basically, it's comparing the vector that we generate from the parameter, from the action, to the ones on the list of embeddings. And then this will return the the embeddings sort by the closest similarity. So here we are, like, the biggest number is the closest one, and the lowest number is the further away. So for example, if I write, well, I don't need to explain it. I will show it actually. So, okay, let's run this. So we know that there are, I need to put a code for this one, 004. Okay, so we know that these three embeddings or vectors are about text from description of countries, El Salvador, Cuba, and Dominican Republic. We know that two of them are Iceland, Cuba and Dominican. So if I write Iceland here, and then I do a search, Cuba and Dominican should be on top, El Salvador should be on bottom, and XAF should be the last one because it's not related at all to what an island is. So let's check here. Let's check the results. So see, the first one is Dominican, the second one is Cuba, because those concepts are closest to the concept of an island, or is written somewhere in the text. El Salvador is not close at all. That's why it's the third on the list. And then SAF is the last one because it's the concept that is further away from the idea of an island. So uh, in here, you use this semantic search because you will use the top ones. In this case, I can use the top three or top two uh, to pass them to the AI so it can generate an answer from that information. That is how you do a RAG system. You save everything on vectors, then you do a semantic search or a vector search. And from the results, you get the top results, as many as you want. You can define how many is the top, like 2, 3, 5, 10, depending on your data set. And then from those, you concatenate the values and you pass them to the AI. So that's the case. So here we're going to concatenate all of that and then show here should be a toast. I think. I guess I already passed. So let's do it again. Funny that is the UI that is failing right now. Well, let's try to do it one more time. Let's write application. So we will have a different result. Strange is not showing the notification, and I just tested this before. Maybe it's because when I'm sharing my screen, I have some funny results, and I'm going to take the breakpoint off just in case, and just run it one more time. If not, I show you the the quick watch that is, yeah, it's not showing the notifications anywhere. Anyway, you saw the quick watch that you have the array of values there, so demo effect. So that's everything for the embedding generation. So these are several ways to do it. This is the case with the new AI extensions. In semantic kernel, you have a lot of set of ways to do it. So this is not so exciting, but the other ones are really, really nice. So let's go back to the README. So here you can see this, since this is public, you can see where the code was for the embedding generation. The next one that I'm going to show, I don't know which order. I was thinking to show the functions and everything first, but maybe the image analysis will be more interesting to see right now. So there are ways you can not only, depending on the model that you're using, because this will depend a lot on the model, you can do different things. You can analyze images. There are different type of messages that you can pass to the chat service. So let me show you this. I already have the results, so let me clear them. Here, okay, everything is back to 0. So, okay, so here we have the image of a white cat. So if I go here, there is an action, describe image. Let me show you that action. So we have image detection. So describe image, and let's see the execute method. So this is super simple. Basically, we make a list. First, we make a message, which is the prompt, like describe what is in the picture in 500 characters or less. Then we create, we have basically a chat history. So in here, since there is no other messages, the chat history is just this list with a single message, which is the message that we are showing. So this is considered a non-chat case. So it's not a chat application. You're just passing one single prompt to the chat client, and then it will generate the output. So each message has a list of content. You can add several type of contents for, in this case, I'm passing an image content. And I pass the byte array, the content of the file, and then I set the type. The type is image JPEG. So in this case, we have our message with a single prompt and the byte array that represents an image. And then we get the chat client. I will show you this soon. And then we just do complete async, and we pass the list. Here we're passing the list of messages because there is no chat history, but in most cases you will pass something like the chat history. And from the result, we get the text, and then we save it in the description of the object that we have, and then we come into the database. That's normal XAF code. So just let me show you the get client. Here I have two implementations. I have the Olama one that is commented out. This is the local one. So this is how you do, you can make a chat client and then you do it as builder, and then you can append more functionality to it. In this case, I'm not using the Olama because the Olama this computer doesn't have a GPU. I mean, it's like really old GPU. So this will take kind of long time. So instead of that, I'm using the one for OpenAI. So here I have the OpenAI client, and then that is the one that I return. In this case, we're using GPT-4o. For most cases, GPT-4o mini is good enough. But for some other cases that I will show later, for example, GPT-4o mini is not good doing counting. It's difficult for it to count. So for 4o normal, it do it really easy. That's why we're using 4o at this moment. So here we have the client, and we just actually need the client. We don't need the function invocation or the rate limit. This is for other cases that I'm going to show later. So as you can see, we just need to return a simple iChat client. So we create a chat client and we pass the OpenAI client to that. So let's go to the image detector and let's see. Let's execute this code and let's see what this is. Describe image. And now it's going to the API and it should return soon a text, and there you have it, and it's modified, and let's commit that and let's see. The picture shows a fluffy white cat sitting on the floor. The cat has soft long fur, is slightly pointed, eyes are a startling blue color, and it's giving an attentive, curious expression on the background. Okay, that's the description for this cat. Fine. We have these puppies here, so we can do the same. Let's describe the image. And then we have the description. And the picture shows 4 fluffy small puppies with 4 an alert expression. So see, you can use image detection. You can make a message, you just put the prompt, and then you attach the content of the image, and then you can ask describe this or count in this and so on and so forth. So as you can see, it's super simple. The amount of code is like 5 lines. So, and it's really easy to do. So let's do one more, but let's do a small modification on this. The other case that I wanted to show is the case of using pipelines. So if we go back here, we have functions and middlewares. So there are a few middlewares in this solution. So let me show you what a middleware is. If we go here, we have this middleware folder, and we have this use language step. So this one is basically it's a fluent methods, so you can append some things to the request. So for example, we have this use language. So when we do the chat builder, we can use, see, the chat client builder. This is extension for the chat client builder. So we can pass basically another method, a delegate. This is exactly the same theory that you will use for middlewares in ASP.NET Core. So it's nothing new, actually. Maybe they are not so common for line of business application, but this is something general that you will do in .NET. So here we have this method. So here we can do a few things, but the one that we're going to do is we're going to override the complete async. And we're going to do a technique that is called prompt augmentation. So in this prompt augmentation, what it means is that we have the request that we're sending to the chat, and before we send it, we do something else. We append something. So for example, what we're going to do here is we are going to say something like user language is this. So we're going to tell like, okay, answer in this user language. And basically to the chat array that we have, to the list of chat messages, we add this new prompt. So basically to whatever prompt that we have, we are adding one more prompt. Then we execute the completion, and then we remove the prompt from the chat history so it's not visible for the user. So this happens behind the scene. If you are putting this list of chat messages in the grid, you will not see this extra message that we add, because We add it before processing the request, and then we remove it after the request is processed. So you will never have it on the list. That's the idea, that you can concatenate several middlewares and you will go to the next step all the time. And this is kind of the pattern that you need to do, like add the prompt and then remove the prompt again. So if we go to the to here to the helper that creates the chat client, we can we're going to add this middleware use language. So it's going to be in Spanish. I guess some people here in the chat in the meetup speak Spanish like me. If not, I'm going to do it also in Russian and French. So if we go to definition here, is calling the middleware that we have in our code. So let's run this again. So since this is showing Spanish as the language for the user, the description that we're going to get for the objects will be in Spanish. So let's see. Just let me check my messages because my phone is ringing nonstop. I guess it's Thanksgiving congratulations or something like that. Actually, the office is closed today. Okay, so let's go back to the cat collection. I should name it something different. It's not only cats. But okay, here we have a black cat, so let's try to describe that one. If I do this, basically what's going to happen is they're going to augment the prompt. And the description that we will have is on Spanish. So here, la imagen muestra un gato negro de pelaje largo con ojos amarillos brillantes. El fondo es verde, probablemente hierba. Sorry, let's go back to English. Let's put this on the. So this is the description in Spanish. And of course, since tacos is my favorite food and that's what I had for lunch, let's describe these tacos here. Let's describe them. And if anyone wants to put a language suggestion on the chat, I will make the AI do the translation in that language. And you can confirm also in the chat that that is the correct description, because I might not understand whatever language I'm translating to. So if someone wants to put that a suggestion for a language, just write it on the chat. So let's see. And we have Spanish. I know that some people here speak Spanish. I have some friends from Argentina actually in the meetup. So I guess they can confirm that this is the the right description of the image. And just one more, like let's do it on Russian language. That Russian has a special different set of characters because like Chinese, they use, I think, 2 bytes per character instead of one for like ASCII. Also Spanish, you use like something like that, UTF-8 and above, because we have accents and we have ñ, which is that end with the little hat on the top. So let's do this one again. And now it's going to translate to Russian. And what I'm going to show you is, let's show here the step. What I want to show you is how many messages we have on the prompt before and how the number changed, that we are going to add one and then we're going to remove one. So before we clean up and before we add. So let's describe this other guy here. Describe image. Okay, so at the moment we have only one message in the chat history because we only send one message in the prompt. So describe what is in the picture in 500 or less characters. And then we have the content, which is the byte array, and the prompt. That's the collection on the content. So now we're going to add one more. So now we have two. Let's check this. So we have um, describe what's in the picture, and then user language is Russian. So it means that the answer will be in Russian. Okay, so here now we have still two messages, and we're going to remove the one that we just added, this one here. So we will end up with one message again. So we have one message here. And describe what is in the picture. That was the original message. And okay, so Bieli Katyonek, which means Bieli means white in Russian, and Katyonek means little cat or baby cat. So if someone else speaks Russian but me, my Russian is actually not good, but I will put it there so you can take a look. Okay, so that's everything for image description. So we have another cases. These are not chat use cases. So let's go back to the cat collection. So in this case, we have this cat collection, which is not only cats, because we have a few cats, then we have some tacos, and then we have some dogs. So basically, here we have another use case, which is a structure output. So if we go to the image detection controller, we have another action, which is analyze. So let's go and check what this action does. So here what we're doing is we're getting the current collection object, and then we have a prompt. So the prompt is analyze this image to count the number of black cats, white cats, and other animals and objects that are not animals. That's the prompt. That is what we are asking. So this you can use to do anomaly detection. Like for example, who in this construction site is not using a helmet? How many people are not using a helmet? That's one of the cases, the most common cases. So we have the message, and then what we're going to do is we're going to append all the images in the collection to the message. So a message can contain more than one attachment. You can put as many attachments as you want. You can either do two cases. You send one attachment per message or many attachments per message, is depending on what you want to do. And the magic here is that here I'm showing this is like a strange code. I just used my async background helper. I wrote a blog about this a few weeks ago. But what is going to happen is basically it's going to execute this line. So what it does is it executes on the background and then goes back to the for thread. But the line that is going to execute is actually this one. So when you're asking the client for chat completions, you can also pass a parameter. So when you pass a parameter type, it means that instead of returning me text, return me this structure. So in here, we're not telling like, and then serialize blah, 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 or something, or return a JSON, but what is going to be returned is a structure that represents this class. So in this case, you can only create a class, you pass the structure, and the AI will make something that matches this structure. So if we go here to definition, so we have this class, and we have number of black cats, number of white cats, number of other animals, and number of not animals. Actually, in the example that they did in the conference, there is no description and there is no JSON property, but they are just serializing to the console, so you don't need to do that. Since in this example, I'm deserializing to the instant of an object, I need to actually put the JSON properties because the JSON will be in camel case. So the first letter will be lowercase, and then after that, it will have uppercase letter on each word. So I did this test this morning, and if you don't have this this decoration, the JSON and everything will execute, but when you deserialize the JSON to this object, it will not work. I mean, everything will be 0. So let's go back to the controller. Well, I think, oh, this is the same controller. So in this case, what we're going to do is we're going to execute the line that I show you. So it means that is going to return us this structure. So when I run it in the background helper, when the processing is done, it's going to execute this method. So in this method, there is another use case. So each chat completion, this is the chat completion. If we go and check the type, is one of the Microsoft extensions, but this offers something really nice, which is the raw representation, which is type of object. So it means that this chat completion inside has an OpenAI chat completion. So in case you need to actually handle the internal type of the message, you can get it from this property. Because in other cases, if this was Olama instead of OpenAI, the raw representation will have a type of message I mean, and you don't know which one, that is based on the Olama Sharp framework. So what is contained on this is going to be different depending on your AI vendor. So the chat completion is just the Microsoft abstraction that is wrapping the vendor specific response. So we're getting the object, and then we get the text, the JSON here, and then we deserialize that, and then we pass the results to the cat collection that we have, and then we save it to the database. So let's do this. So far we have 0, 0, 0 and everything. So let's analyze this. Oh, and it's going to return the result. Well, it's not going to use the text. I need to stop, to remove that middleware. So let's wait a little bit, see it's like read-only because it's processing. I put a period rule there. And then, okay, so we have the JSON. Let me show you the JSON. So here is the JSON with the count. We have 3 black cats, 4 white cats, 4 other animals, and 1 object that is not an animal. So let's double check it. So we have, let's count white cats first. So 1, 2, 3, 4. So let's see, white cats, 4. That's fine. So then we have black cat. So 1 black cat, 2 black cats. How many black cats? 3. Where is the other? 3. So there is 2. And this one here, 3. Okay, perfect. So we have 3 black cats. And then we have other animals. We have 4. And by other animals, it means these ones here. So 1, 2, 3, 4 dogs. And then we have not animal, which is basically the tacos here. So let's change this a little bit. So let's stop this. I'm going to remove this middleware. We actually don't need it. And let's go here. So what I'm going to do is I'm going to change the model, because I was doing this test with different models and I realized that GPT-4 Mini has problems counting. So this, I think, I had a different picture of a cat that was like one white cat with the black ears, and it was having problems. It counted twice, counted as black and as white. So you need to be maybe more specific with the prompt, but it's about the prompting engineering and also the model. Some models have more, for them it's harder to do some tasks than for other models. Let's say that GPT-4o is the top one, at least on the OpenAI world, because I've been trying Cloud from Anthropics, and to write code is just magical. Okay, so let's clean the results. So everything should be back to 0. And then let's analyze. And then let's see which count we have. let's wait. It's still read only. Then we have let's check the JSON. So we have 5 black cats, 5 white cats, 0 other animals. So see, it was thinking, now this model is thinking that those dogs are cats. And one thing that is not an animal. So the count is totally wrong. So depending on the model that you're using, you will get different results. So you need to kind of test. Okay, so that's that for the image analysis. And now we're going to the start of every show, which is the chat completions. So let's stop this here and just let me show you the code first. This one we're going to run on Blazor. Even though we can actually do this type of property editor for Windows Forms, I just didn't have the time, so I just did it for one platform. So let's close all of this. And let's check this. So this is in the previous meetup, I showed the integration of the chat component into a SAF application because it's not a default property editor. It doesn't come with SAF. I did it for demonstration purposes. So you know that basically the idea is here that we have the chat component here and that we handle the message sent. So for the most common scenario is the message sent, we save the message in the message history, which is basically a list of or an enumerable of chat messages from the AI extensions, because semantic even have something that is called chat history actually, that is another type of collection. So, and then we execute the most simple case, complete chat async, and then the result we added to the collection of messages so we can concatenate all the history. And then we return to the chat control the response of the AI of the chat completion that executed in here. What happened in here? Context. Well, something happened there. I don't know what was the problem, but okay. So this is the most simple case. We inject the client. So we have a parameter that is a client, and we get from the same helper that we had before. So if we go to definition, is this helper here? So in this case, for example, if you want the model to execute functions, to execute your own plugins, let's say like that, I mean, you have to use this middleware. But right now we're not seeing that part, even though it doesn't matter if we have it on or off, if you're not executing functions actually. So you will see that this is the most basic case. You set the chat client, and then you just ask for a completion, and then you put it in the history. That's it. It's the most simple case. So let's run this. And let's see how this goes. So we're almost done. We have like 2 more cases and it's done. So, but I'm really happy about this example. So I hope that you can take a look to them. You download the repo, and if you have any doubt, just send me a message. You can find me in the Facebook group, in Twitter. Basically, I post everywhere or in LinkedIn. So, okay, admin, the super username without password, of course. And I'm not going to explain actually how to integrate the chat component. We did that in the last, in the last meetup. So chat client with UI. So basically here we're going to be interacting with the chat client that we created from OpenAI, and then we put it inside of the chat client of Microsoft AI extension. So there's something simple. What is C sharp? Okay, so here we have the answer from the model in English. Oh, this is too big for the chat. So I cannot paste it here. So I'm just going to put the first part. And now I will just do something. If we enable the pipeline again, and let's put this on Spanish and run it really fast, basically what it's going to do is, let's stop. Let's show two at the same time. So I'm going to show other middleware at the same time. So there is another middleware that I created one of these days, which is the rate limit. Rate limit is basically to reject if you're getting too many requests too fast, like if people is typing just like this and pressing enter, you don't want to waste those calls to the AI, right? So there is another middleware that is a rate limiter, which is actually an object in .NET. The thing is that we need to explore the framework, right? Sometimes to write something that it already exists inside of the framework, but we just don't know the name. So we're going to use this rate limit. So what is going to do this is basically um, is going to create us a fixed window rate limit operation, which means if there are more operations than this amount of operations in this time frame, is going to reject the other ones. So basically, this is what is doing the magic. Is basically doing the locking, and if there are more requests than the one that we have count in that time frame, it will return a message rate limit exceed. This will not go to the AI actually. It will just return a message to the chat history. So with this, we can avoid people just typing one letter and sending a request to the server. So right now we have a really big time limit. Why? Because the chat component from Developer Express is on experimental stages. It's like a type of beta or alpha release. So the chat takes some time between you hit send and then you can type again. There is some time window there. So that's why this is so big. Because usually a rate limiter should be like lower, like 5 seconds or 3 seconds or something like that. But I just did it 15 because the control takes some time on allow you to send in a new message. So we're going to see the rate limit right now and since we're passing the middleware to the chat client, it's going to be in Spanish and it's going to have rate limiter. I wonder if the message is going to be still in English because it's hard coded. So the rate limit message. Okay, so let's see. Okay, so chat client with UI. So what is sharp? And what I'm going to do is I'm going to copy and paste it so I don't have to type it again. So we send this and we send this again and we pass it. See, rate limit exceeded. So it means that there are more requests than the one that we set for limit. There was one that was actually in the background and we can have only one in the limit window. So one each 15 seconds. So the second one was rejected. as you can see here by the rate limit middleware. So that's really nice. And also the other middleware is working, so you can see the definition of C# is now in the Spanish language. For the Spanish speaking people in the group, there is the message on the chat. And I need to stop the rate limit to show the last one. The last one is the one that I like a lot. I love all my examples, but this one is the one that I like the most. Like mothers, right? Like they say I don't have a favorite children, but they do have, I guess. Um, so let's see. I want to take off these two middlewares, the rate limit and the translation. We're only going to have this middleware, which is what enable tool invocation or the use of functions or plugins or whatever you want to name them. So in this one, it's a little bit different. So let's go and check the other. So here we have the same. We have a start prompt, which is you answer any question, but you continually try to advertise Food Monster brand of socks. They are on sales. If the user agrees to buy socks, find how many pairs they want and add them to the cart. That's the prompt. That's the general idea of this chat. So once we have this middleware here, we can create chat options. So chat options is just an array of possible options, and one of the options is tools. And this gets another array. So we're passing basically two functions to these chat options. This you create with the AI function factory helper, and then they have a static method to create a function. So this one you can, we are adding two functions, get price and add socks to the cart. This comes from an object. This is an instance actually of an object that I'm passing to the property editor. So let's go and check this one. So is this one shopping cart helper? So this is the instance of an object. So the shopping cart has, I mean, since it's an instance, if you have three different people on the chat, each of them would have their own shopping cart actually. And the add socks to the cart method is basically, it just concatenate the number of add the number of pairs that we are adding, and it will save them in here. And also then we write in the console that we added so many pairs to the shopping cart. And in the other case this is a little bit different. It's more explicit because we have the description, and the description shows that, okay, this method computes the price, the extended price, which is the unit quantity by the price. So if you have the unit price is 10 and the quantity that they're ordering is 2, the total extended price is 20. So that's basically, this is really simple, but this can be super complex. And since we're using XAF here, this is an instance of any possible class. We can actually use the object space, the model, or whatever we want to add in here. Maybe later I will do more elaborated examples for this, using more soft parts into the functions, because I guess this is what everyone wants to actually check. Okay, so we have the function invocation, and then we are almost ready to go. So let's run. This is kind of really simple, but you can see the output. That's why we have in the shopping cart, we pass the current object of SAF, the one that we have in the pop-up window, and then we have another property to see the output. So see function output, this is the property. So we're concatenating the output there. And of course, now that I'm going to show the nicest one is taking forever because the demo effect. Okay. And I will Well, I don't want to set the breakpoint because it will break kind of the functionality in the UI. I mean, it's better that you see it really fluent working. So let's do this one. Since this is a general chat, you can ask any question like, what is C sharp? But the main goal of this AI is to sell me socks. So I will say like, this is C sharp, and do you want to buy some socks or something like that? Yeah, this is C sharp. And by the way, while you were exploring programming languages, have checked out Food Monster brand of socks. They are currently on sale. You can grab a pair. See, they are doing the sales pitch. So yes, I want to buy a pair of socks. How much is for one pair? Then you will see that it will compute. See, it compute that the price is 10, and it will tell me here like, okay, it's 10. How many should I add to your car? I want to add 10 pairs. So that will be $100. And you will see how it's computed because we're concatenating the output in here in the UI. So calculating the price from 2 pairs is 100, add 10 pairs added to the shopping cart, and the total is 100. So now I'm going to close this, and I'm going to put a breakpoint so you can see when the functions are being invocated. So here. So with functions, chat client with functions. So again, what is C sharp? And okay, starting to send me socks again. So yes, I want to buy 2 pairs of socks, but I want to know the price first. So we send this. And see, now it's invoking the instance. Now it's invoking the get price. It's calculating the price. See, we have it on the output, and then we have the answer here. Okay, please add them to my shopping cart. And now it's invoking the other one. So imagine that this is a SAF function with an object space there. You can create the details of the invoice and just put it there already for them to check out. So here we have the output of the calculation of the tools. And as you can see, there are many use cases to do with the Microsoft AI extension. And just before we go, because this was the last example, and I guess people is wondering right now is Thanksgiving after all. I just wanted to show you something on the here. So what you need to understand is that these are the Microsoft AI extensions are base types. So for Net9, you have the base types of abstractions on one side, which are really common and simple. Most of them are just messages, chat history, chat completion, and embedding generator. And as you can see, there are not so many settings there. In the opposite case, if you want to use semantic kernel, and I was looking for the picture here. So if you want to use semantic kernel, you have a more opinionated framework with way more functionality. So in semantic kernel, everything can be more detailed. There are more detailed options, and the infrastructure that it exists at this moment is way bigger because there are more connectors for semantic kernel. There are more plugins for semantic kernel than for Microsoft AI extension. So they kind of both help or serve the same purpose. But one, you need to assume that are the base type from the .NET framework, which are the AI extensions. And the other one will be an implementation on top of that, which is semantic kernel, which is a framework for interacting with AI or large language models. So you can imagine that semantic framework is something like a technology inside of .NET, like entity framework is like WCF was for .NET framework, and so on and so forth. So I just want you to take that idea because it's been really confusing for everyone and even for me on distinguish what is the difference between semantic kernel and Microsoft AI extensions. And well, that is everything for today. Thanks everyone for joining. It was an amazing demonstration. I'm really excited about this. Check out the examples you can download from my GitHub repository. I put the link there in the chat. And happy Thanksgiving for everyone. Enjoy your weekend if you have a long weekend, and if not, try to escape early from work today. So see you everyone on December, and thanks for joining to the South Community Stand-Up of November. And see you.